So, okay, well, I will start. We are developing a different seizure detection device. Okay, here we go. We are developing a different seizure detection device because there is a need. The focal seizures are among the most common ones, and at the same time, they are the most likely to be pharmacoresistant. Last year, experts from Eli reviewed existing solutions for focal seizure, and they conclude that it was too early to be recommended yet. We are focusing on identified weak spots, increasing the performance of such devices, sensitivity and false alarm rate, and also making sure that it will have a positive impact in patient daily life. We target the 60% seizures that are correlated with tachycardia. We measure EKG on the chest, and we combine it with body movements in order to get contextual information about the user activity. We then proceeded by artificial intelligence. With our great AI team, we decided to go for a crowdsourced approach. It has been demonstrated that it's very efficient in epilepsy data challenge. We structure a large and qualified data set. And what you have to know is 80% of the work in AI is data cleaning and data processing. We built such robust procedure. We shared it with researchers. It is now used by thousands of researchers around the world. And we get access to a living lab at LATEP Institute. It's a medical center that takes care of 450 patients with a staff of 400 healthcare professionals. It allows us to monitor various daily activities in order to lower the false positive. We have already implemented the first AI model. We are now preparing 2 pilot studies with this medical certified patch from the MoveSense company in order to evaluate the performance of such AI model in real life and assess the impact on patient quality of life. So we expect to combine one of these patch, industrial patch, embed our AI seizure detection algorithm to get an autonomous, affordable device with a personalized alarm system. So we are launching a product using open source framework, as it was done for the famous operating system Linux. Tech communities developed this software in open source that has been then commercialized by various companies such as Red Hat with great success. This Linux system is now running on 2 smartphones out of 3 in the world at an affordable price. It's a win-win collaboration between non-profit communities and companies under non-proprietary licenses. ONGO, it has been founded by passionate engineers like me that want to contribute to projects that make sense. We have been joined by plenty of contributors, and we strongly believe that we are releasing the first open source AI seizure detection algorithm in real life by the end of 2023. And now we are looking for industrial partners that could take our work, embed it in their medical device, and make it accessible widely to the user, and to make our 5-year hope-bearing projects come true. Thank you.
Thank you, Clement. All right, I'll open it up to our sharks who would like to pose the first question.
I can kick off if you'd like.
Sure.
So Clement, I like your idea of having an open source platform. My question is, suppose an evil genius, such as Martin Shkreli, comes along, who's recently released from prison, and sadly, he's misunderstood. He is. And he's not able to make his own medical devices anymore. So he sees yours and he decides that he'll collect up all the patents that he can find, and he will try and extract patent royalties from your organization and all of your clients. In a traditional company, there would be a litigation department. People would have a means of fighting them. how does an open source platform fight the next Martin Shkreli?
That's a good question. First, I would say the first mechanism to defend, because even patents can't protect for big billionaires. We saw some movie on Netflix. What's the most important is the community. You have to be known by the community, by the healthcare professionals, because they recommend the device. And so if we're in contact with them, that's the first step to defend their ideas. Second step could be we have what we call a GPL licenses. It's a non-permissive licenses, which means it could be used for research very widely, but it can't be commercialized if the people that commercialize the product don't release it as open source or don't share the same values as the community.
Thank you.
I have another question. I think that this is very much needed to bring together a lot of these different variables together for seizure prediction, detection, and to integrate with the whole family unit taking care of a patient. But in this case, you're using a wearable on the chest wall, and just how your team has thought about the how comfortable that will be, whether patients will be willing to do that in the long term, which would be required to make this useful.
That's also a good question. That's why we are working close end-to-end with LabTech Institute, because we are evaluating the acceptance of I would say, how they get control over it, they used it over a long time. That the purpose is during the study to check if it's not going to be dropped after 1 week. But we already have focus group. We already have interviews. We already have quiz with First French Patient Association, and the feedback are quite good. Not everybody is going to wearing it, but some people will do, because it will have a significant impact on their daily life.
So, so this is one on the chest,
Yes.
right? And have you, right? I saw you showed us off, so it looks interesting. Have you looked at, so most movement detectors, I think, have been on the extremities, right? To look at repetitive movements and things like that. So have you looked at how that will work, as far as, because that's a component of what you want to do for your prediction algorithm, right?
Exactly. I would say the body movements are more to get contextual information. It's not directly, if we can get some seizure information, it's great, but the first role is to limit false alarm rate. Am I jogging? Am I lying in my bed? Am I running? In some situation we can catch with the body movement. And even some seizures, they don't have like motion on arms or on the other arms. And so you have it at the armrest, but it doesn't provide any information. So it's a different way of doing it. I'm not saying we have to give up about the armrest that we saw just before. We need multiple devices, and more also we need to get different approach to see what is the most robust for a single patient, to get a personalized approach.
Okay, we have time for one more question. Dr. Moore?
I'm sorry to push on the patch, but I'm assuming the patch has to have some type of a battery in it, and how long does it last? And how often do you have to replace the patch in general?
We placed it under the torso, either here or in the middle. You choose. It's quite discreet. This one is a little bigger, but some industrial are smaller. We are going in the miniaturization process. Not us only, I mean industrial in general. And for your first question, patients require at least 3 days of autonomy. So it has to be changed. You can unclip it. You drop the adhesive part, and then you reclip it with a new adhesive part for 3 days.
Thank you.
Thank you, Clement.
Thank you.